Good and robust data is essential for accurate market sustainability and criticality assessments. Data on critical raw materials provide an understanding of the geological presence and material flows and stocks across value chains. We use many different types of data in such assessments, and some examples include material production statistics, whether on primary or secondary raw materials, trade statistics, waste statistics, commodity price data, material footprint data, and many more. Data availability can vary considerably between different commodities, and in the case of critical raw materials, it can be particularly challenging. Such challenges are often unique to a commodity. For example, production statistics of rare earth elements are often based on estimated figures, as disclosure of data is very limited. Mineral production data on lithium are highly variable from one country to the next and require substantial interpretation and analysis to make them comparable. This is due to the geological variability of lithium deposits. Overall, however, data availability is influenced by the special location of data. For example, some countries may report good data, but others none. The material identity. For example, some commodities may have better data coverage than others. The supply chain stages. For example, statistics associated with primary production are better documented than production statistics from secondary raw materials. The trade of commodities. For example, current nomenclatures do not deal well with critical raw materials because they lack the required detail. The purpose that a dataset serves. In many cases, we use datasets that have not been developed for the questions we're trying to answer. As there's no alternative source, for example, we use statistics to understand secondary resource availability. All the above have direct implications for the quality of the assessments that we undertake. There are notable gaps in our data collection, such as explanatory information on the data we collect, or as data scientists refer to metadata. Just to give you an example, mineral production statistics may report the quantities of ore or concentrate produced, but do not specify the metal content. Consequently, this has to be estimated, adding uncertainty to our knowledge of the quantities of metal produced. Other significant gaps are the lack of statistical data on the production of different material forms, limited information on available stockpiles, lack of geological data on resources and reserves, and many more. One important point to remember is that just because data is not available for part of a material system, it does not mean that part does not exist.